test today because we need to get in a good spot for tomorrow. Take a look at what's up there. Let's start off, please, with the first question from Assessment 46. Taking a look at what's up there, how would we figure out, Grace? Well, when you see common ratio, what's something that you know that we're looking at?
Honestly, I have no idea. I don't like this question.
Yeah. Yeah, this is going to be a geometric progression. How can you figure out what the common ratio is going to be? Hands up, please, when you can tell me. We got 1, 2. This is not good for us. What do you want to say? Absolutely right. So let's take the second term, which is going to be negative 3 over 32, a cubed, b to the 4th, and we're going to divide it by the term before it, which is 1/64, a to the 5th, b to the 3rd. Looking at what's there, you need to find the common ratio by dividing them. So let's start off. We can either do the fractions, the a's, or the b's. Sam, which one do you want to do? The fractions, the a's, or the b's? Okay. What's going to be left when you do the reduce out the b's or do this division, and where? Where? Thank you. Looking at the next part of it, count it. Which one do you want to do, the fraction or the a? Okay, what's left after the a's, and where? Okay, a squared is going to be in the denominator. So now the part that you all left for some reason, even though this is probably the easiest part, is the fraction divided by the fraction. You literally go into the calculator. You can use your nose if you want to press the buttons. Get that in there, and Royce, tell us what you get and where after you reduce those fractions. And where is that negative 6 going to go? And what? Because what's negative 6 is a fraction. This is the same as negative 6 over 1. So this would be your final answer. Questions on that? That's it. Use the calculator to help yourself out. You could multiply by the reciprocal. I don't care how it gets done. But on the read, you'd always have the calculator available to you. Take a look at the next question. And Thomas, what would you do to answer this one out?
I started off by dividing along, but I don't know it.
No, and you need to know how to do this. This is one we can't miss. None of us should be missing at all. We got 3 that can answer this. Really? Really? Tommy, what do you say?
I did 27 to 4/3
Equals?
2x.
There you go. So if you don't have it down, get it down now. When we're doing this, you should also know what this is and know how to evaluate this without your calculator. So, looking at this, Sean, Al, what would you go through and do? Look at the exponent in and of itself. When you do this, what does the 4 represent and what's the 3 represent? Okay. So, if you don't have a calculator with you, which one's easier to evaluate? Is it easier to take 27 to the 4th power or the 3rd root of 27? Which one? 3rd root. Hands up, please, when you can tell me the 3rd root of 27. These are things that you're supposed to know. 3rd root of 27, what? 3. Now take 3 and raise it to the 4th power. You don't need a calculator. 3 to the 4th, you shouldn't need a calculator for it. What? 81. So we've got 81 is equal to 2x minus 1. From here, what would we go through and do to solve, John? So what do you get? Equals. And then? And get? Questions on that? You can do n solve to check your answer as well. Take a look at the next one. If you've got to solve this out, first of all, Anthony, how many answers are we going to have? So what would you do to solve this out, Anthony? So we've got x to the 4th plus 4x cubed plus 4x squared plus 16x is equal to 0. What happens now from here, Mickey? Take an x out from everything, and what's left? and I use brackets because I know what's coming up. Looking at what's there, my next step, if this is what I've got, look at the remaining polynomial that's inside the brackets. Hands up, please, if you can tell me what we would do in order to get our answer there. Go ahead. So what would you take out from the first two? Nope. Squared, yeah, and what's left? Keep going. And then you're left with? Now, looking at what remains on the inside, and yes, you need to equal 0. Looking at this that remains on the inside, you can factor this again. Technically, what you've done right here, you said factor by grouping. That really is triple GCF factoring. You took a GCF out from these first two here, and you took a GCF out from these two here. That leaves us with this big expression. However, what can we still do to that big expression that's in there? It's just an awkward binomial, yeah. Well, I'll say this. What type of factoring did you just do? Because it's not going to be grouping right there. Look at the left and right halves of this binomial. Yeah. A GCF, and what is the GCF, or what common factor do these halves share? You're taking out an x plus 4 that they both share, and what does that leave you with? X squared plus 4. Now, to go forward from here, you've got 3 terms. Looking at those 3 terms, I go through and set each one equal to 0. You're going to get one answer right away. And then over here, x squared plus 4. Why does x squared plus 4 not factor down further? Hands up, please, if you can tell me why x squared plus 4 won't factor down. It's got to be a difference of perfect squares, which means subtraction. So we've got one that's already solved for. Kristen, what would you go through and do? Which one do you want to answer next? And what do you get? Okay, so that's my second answer. For the next one up, Philip, what do you need to do? So you've got x squared is equal to what? And what do you do from here? And you get what? And you get what? And you get what? Now, there's actually a function on your calculators if you go in, where it says you can go into, I think if you go into number, go into your calculators right now, stop staring. We actually do things when I ask you to. Go in right now, go into where it says, excuse me, is it not number, it's under algebra, I think. Where do we find polynomial tools? Which one is that under? Algebra for 3. Go and select then C, complex polynomial roots. So make that selection. Don't stare at it. Go find it. And now go back and type in what this polynomial is, which means everything has to be set equal to 0. Just that, though. Type in what the polynomial itself is going to be, which means you get it all to one side. Don't put an equals there, because it's not. It's telling you the roots of the polynomial. So type in the polynomial, comma, x, and press enter. So I'll be going through and do that right now. I think that that's the correct syntax on the calculator. Who's got that typed in? Who's got it? You do? Let me just do it for just 1 second. Let me just double check and make sure it's right. Yeah, so you do C poly roots, and you type in the polynomial expression, comma, x, and how many roots does it have? 4. And do you see what they are? So you can see right now, that's why none of you should ever miss this question, ever. Are we clear? The algebra needs to be there. And this was one of the things that's interesting too. If you forget the plus or minus, the calculator will remember. The other way to remember the plus or minus is this. How many answers did we say initially that we were going to have? 4. And if you forget the plus or minus, how many will you have? You'll only have 3. Now, we're going to do this quickly. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So we have 22 people in here total. We're going to go through and do a little bit of a quick survey. I'm going to make sure I remember that there's 22 of you. What you all are going to do, and this is so, I don't know why we do this, but if I had asked you, let's say this, if I had said that right now there was money that was taped to the ceiling and you can have it as long as you don't, as long as your rear does not leave the seat, how would it look if you were reaching for that money? Go try right now. Reach for money that's coming down from the ceiling. See? Okay, let's just nice and high. We're not doing the deodorant check here. Nice and high. Get it. There we go. Nice and high. Extend all the way out. Like this. That's how one raises one's hand. Okay? So when we're trying to do a survey of people, I don't need some sidearm pay. I need you to way up here. All right? Now, looking at this, out of our class, what's the probability? Now, looking at what's there, hands up please if your favorite color is blue. And I mean this way. Nice and high, you get to vote. All right, so we have, and voting is now done. We have, no, keep your hands up if you voted. Stop, because this is the part that gets irritating. Some people can't follow even mild directions, and then all of a sudden our numbers get up. So your hand is like this. Thank you. 1, 2, 3, 4, 5, 6, 7. All right, so out of our class, probably that a favorite person's color or a person's favorite color is blue is 7 out of 22. Out of our class, what's the probability that a female is selected? So girls, right now, raise your hands. That means you actually do it. It's not an option. Yes, all of you. All of girls, like this. We've got 1, 2, 3, 4, 5, 6, 7, 8 girls. Is that right? Okay. 8 out of 22. Now, if a person is chosen, or if a person chosen is female, what's the probability that their favorite color is going to be blue? So let's do this. Raise your hand if you are a girl and your favorite color is blue. Nice and high. There we go. We've got 1 out of. Now, this is where it's awkward. Read what's there. Hands up, please, if you can answer that question. If the person chosen is female, what's the probability that her favorite color is blue? Hands up, please, if you can tell me what the answer to this question would be. Riley? 1 out of 8. There's 1 girl with that as her favorite color. And then, because it's not going to be out of 22. Because there's only 8 girls here. Out of the people whose favorite color is blue, what's the probability that that person is a female? Hands up, please, when you can answer that and give a justification for it. We've only got 2, and this is a part of statistics where you have to read in these situations. What do you want to say? 1 out of 7. Why did you say that? There you go. So your probabilities, and these are one of the things that it gets awkward when we're doing this, because I can't tell you, or I guess we'll say it this way, I'm not a reading teacher. As someone who's in here, understand that these questions require a lot of reading, which means you have to take everything you do and temper it with a dose of reality. Because again, some of us think that we're 100% all-stars every single time. You have to read for meaning, and you have to make those connections, because there's distinctions that are within the question, especially like C and D, where if you're not following through and or you're struggling with what it's saying, it's going to be difficult for you to get the question right, just because you're not unpacking the question correctly or getting the information out that we need you to. Take a look at the next grouping. It says, here's our notation for conditional probability. Conditional probability is something happening given that something else has already happened. So what's the probability this happens given something else has already happened? Now, our conditional probability we listed out as B bar A, and that bar means given. So when we're doing it out, here's our definition. The probability of B given A has occurred would be the probability of B and A occurring. That's what the A means, or that's what that upside down means. It means and, given that A has already occurred. Keep in mind that this, when we're reading it, means given. Questions on that? All right. Now, we're going to get into some examples of this, and you have to make sure you're reading for meaning when we do it out. And by the way, just so you're aware, and please understand, at least from my point of view, I took stats once. I struggle with reading. I didn't take stats 2 and 3 for a reason. It's too much reading. I'm an algebra person. I like to solving for x. I don't like reading. It tends to involve feelings at times. It tries to open your heart up to outside experiences, which is why I'm so closed off from others. What I need you to understand is when you're doing the questions, I don't reduce my fractions in this unit, at least until the end, for a reason, because if you reduce, some people get lost along the way. Like if we're saying something happens 2 out of 8 times, that's acceptable for us. I don't need you to reduce it until, the very end. Sometimes the reads won't even reduce it. The reason being, if I was going through and saying, what's the probability of, even in the first row here, right? If I said, what's the probability of selecting a boy out of the first row, I would probably say it's 3 out of 6 to you instead of saying it's 1/2. Why? It means that there's 3 boys in the row out of the 6 people overall. Some people, if I immediately went to 1/2, people going, why is it 1/2? There's 6 people in the row. Your denominator should be 6. So understand that as we're going through and doing these questions out. Now, looking at what we have, you're going to be seeing tables like this galore. And there was one, actually, that was on the last question, and unfortunately, I got tasked with grading it, and I was ready to stab my eyes, because I kept sitting there, and you have to work through people's wrong work if they do something wrong, which is why I'm so invested in you getting it right, because I don't want to have to look at wrong work, because I get confused on these questions and lost very easily. So, looking at what's here, we need to find the probability that someone likes a comedy given that they are in that age range. So, how would we determine the probability that someone likes a comedy and is in that age range? Well, we need to break it down. We need to find the probability that the person goes through and likes a comedy and is in that age range, the 26 to 49, all over the number of people. And what would our denominator, I guess, be, Megan, that we're dividing by? Probability of what? Or the number of what? 26 to 49 people. Now, look at the table above. What's the probability that someone likes a comedy and, we'll say this. What is the number of people who like a comedy and are 26 to 49? Hands up, please, when you can tell me what the numerator is going to be. We got 4 people. That's not good. Look at what's there. McKenna, what do you got? 472 over the number of people that are 26 to 49, and that's what we would get. To find the probability that someone likes a comedy, given that they're in that age band, we need to find the probability that they're in both over the number of people in the age band. Questions on that one? Try the next 2 then on your own right now. And I would strongly advise you writing out this middle step, because you're not going to be able to follow us easily if you don't. You have to get used of how to evaluate those probability of an event given something else, or a conditional probability. take a look at what we have here and let's do the setup. This is reading going across, the probability that someone is over 50 given they like horror movies. So, Thomas, how would you break this up? What would you write out? Probability of what in the numerator?
4, 50 or 50 plus,
Mm-hmm.
and 4,
Okay? And you're going to divide it by?
4.
There you go. So look at your table. What's the probability, or what's the number of people that are over 50 and like horror? What would you go through and say?
190
Over.
680.
And you said how much at the denominator?
680.
Good. Good. 190 over 680. Next one up. Now these are different events. It's the probability that someone likes horror given that they're over 50. So looking at that, don't worry, it's the T today. Nick, what would you go through and list out for us?
The probability that someone likes horror and is over 50, or given that they're over 50.
So the probability that someone likes horror and is 50 plus, given that they are over 50. So what's that going to look like?
190. Probability of 190.
Good. Over?
Over 1,000.
1,000. How is B different than C? They're very different things. How is B different than C? Hands up, please, if you can describe to me how B is different than C, because there's similarity there. And this is when those of you that are readers, that are truly like enriched readers, should be able to decipher what this is. What do you want to say? Mm-hmm. There you go. So what's the same is the number of people who like horror and are over 50. That's going to be the same. What's different is the pool that you're drawing from. Because, John, in this group here, it's 190 out of, what are you looking at? What's your divisor? There you go. So if I said everyone who's a horror movie get into this room, and I have 190 that were over 50. Where this second part is I said, all right, get in the room if you're over 50. And then figure out how many of you like horror movies. So it's a different initial categorization or initial screening that was done. A company wants to sell a product designed for young adults. They want to advertise in a movie. You tell me which one should they choose and why. Read what's up there. Which one should they choose and why? We've got 2 people who can look and make some conclusions. This is the analyze part. This is everything comes together. You're an executive. Who are you? And if you go to the movies, you'll know there's a specific type of movie that you see or a specific type of preview based on the movie that you're going to sit in. Which one do you want to say? Okay, why? I want to add, I wouldn't say that just yet. Yeah. No? Well, yeah, but I still, what's my reasoning for picking it? Yours was closest, but you didn't say something in there that I want to hear. We'll say this. I want it to say like it's got the highest likelihood. It's got to say probability. So what was your answer again? What did you want to say, Grace?
I just said 450 out of the 1,000 like comedies, action and horror are less than 450.
I'll say this. It has the highest of being liked in that age group. Now, a company wants to advertise to older adults. Which genre would be the least beneficial to advertise in? So I'm trying to advertise to older people. Which one would be the least beneficial for me? McKenna? Why? Now, I'll tell you right now, this actually comes up all the time. Certain shows that you all watch, you will notice, have certain advertisers. Certain shows that you watch have certain advertisers. One that I always used to laugh at, but it's very, very true. Think about if, well, I watch Judge Judy all the time. And on that show, they have the same set of advertisements show up all the time. There's some sort of online college. It used to be, what was it, Everest Institute? Raise your hand if you remember seeing those Everest Institute commercials that were on, and they're like, yeah, I go to college in my pajamas. There was actually a commercial, by the way, that was like a girl being like, I need to find the best online school for me, and blah, blah, blah. And by the way, if you can go to college in your pajamas, it's not really college, just so you know. The second thing that they always advertise for is, and it's not to make light of it, but I don't know how there's this much overlap, the mesothelioma class action lawsuit commercials. And it's always like, do you have mesothelioma? Do you have some mesh implant that went wrong? Do you have a hip that's dysfunctional? Did you smoke cigarettes for 40 years? Did you? I mean, there's every medical malady. Now, what type of people are you advertising to? If you're looking at that, there's two types, which I apparently get lumped into. I'm within that target demographic, is somebody who's either really old or really sick. That's who's going to be suing people for health problems. Or people who are looking to get free money, which, let's be honest, if you get injured by a car and you go to Celino and Barnes, or injured by a car, call William Mattar. There you go. See? 444444444, I think is the number. In any case, I know somehow I'm in that pool of people because that's all that's advertised on Judge Judy all the time. And is that commercial going to be showing up on, watching some fine arts show on PBS? Probably not. Probably not. So understand, like, that's the demographic that you roll with. Now, take a look at questions. Let's see if we can do some more. Yeah, so I did this next one out, and there's something that we need to go through and do. So read the table first, I guess. Read the table first. And there's some banding that I sort of do when I'm making this table. But there's one thing I need to know that isn't indicated by the table, but that I can easily compute before I answer out all these questions. Who can tell me something that I probably want to extrapolate from this table before I go further? Yep. How many total people are there? Hands up, please, when you can tell me the total number of people involved in this survey. We got one person, really? Really? Two of us? Three?
1,900.
Yeah, it's going to be 1,900. So I always list this maybe like in the margin. Total is going to be 1,900. That's just so I don't forget it. Now, I made some bands. So over here is going to be improved skin. Going across means that their skin improved. Over here is going to be no improvement, so I'm going to write an N for no. And then over here, I'm going to put down these people use the cream, and this group use the placebo. So I've got some letters there that's going to help me with my probabilities. Now, take a look at the first question. And you have to ask yourself, is this a regular probability or is this conditional, meaning something given something else has happened? So looking at this one, if a person used the acne cream, what's the probability that the person's skin improved? Is that direct probability or conditional probability? Hands up, please, if you can answer and why. Which one do we think? Read out what A is. Is it direct, just plug in? Or is this something given something? We've got two of us who can answer that question. Come on. And this is the part. I can't teach you how to go through and read. What are we saying that this is going to be? We got four of us?
Conditional.
It's conditional. So you're looking at the probability of what given what then? Yeah. What is the given part of it going to look like though? So I'm going to go through and say, if the person used the cream, what's the probability that it improved? So who are you drawing from, I guess? What's your subset that you're pulling from? So it's something given that they use the cream. And what is that something we want to have happen? The skin improved. So it's improvement given that they use the cream. Now, how would we set that up? We would need to find the probability that they use the cream, or that they improved and they use the cream over the number of people that use the cream. Go through right now and compute out what that would be. Hands up, please, when you can give me an answer. And this one's going to be awkward. You've got to go through and read and see what's there. Corey, what do you think?
Is it 800 over?
Perfect. 800 over 1100. Questions on that? Take a look at B. Out of the people who saw no improvement in their skin, what's the probability that they use the acne cream? So, is this direct or is it something given something? Which one? Is it conditional or is it direct? Marissa D, which one would you say? Yeah, it's going to be conditional. And what are the conditions on this going to be? It's what given what? Hands up, please, if you can answer that. It's going to be what given what? What needs to, what's the, you tell me. Yeah, sure. Yeah, so which one goes first? No? It's going to be that they used the cream but saw no improvement. Out of the people who saw no improvement. So what's the pool you're pulling from? The no improvement people. Find the probability that they had no improvement, or sorry, probability that they used the cream given that they had no improvement. So looking at that, you would go through and find the number of people who use the cream and no improvement over your no improvements. So what's that going to go through and look like? You tell me. What's that going to go through and look like? Yeah, 1, 2 of us. You can tell me what's your answer going to be for this. Oh, come on. Come on. Okay, what do you say? Couldn't hear you. What was the numerator? Yeah, 300 over 500. Questions on that? Next one up. What's the probability that the person used a placebo and their skin improved? Is this a given? Or is it conditional? It's a straight up given. What's the probability that the person used the placebo and their skin improved? You tell me. This one hopefully should be easy for us. What's the probability that the person used the placebo and their skin improved? What would we say that that's going to be? We've got one person who can interpret and read. Tammy, what do you say? $600 over what? No? Who can tell me my denominator on this is going to be, Ben? Why is it going to be 1900 here, Ben? Yeah, it's just as a person in the study. Take a look at the next group. What's the probability that a person who used a placebo saw an improvement in their skin? Is that conditional or direct? Which one would we say? Hands up, please. You can tell me. Would this be conditional or direct? I've got one person. Sean K., what do you think? Yeah, it's got to be something given something. It's a conditional. So looking at that, Riley, what needs to happen? What's the pool, I guess, you're drawing from? Maybe for us setting up the second half of it's going to be easier. Where are you pulling from? What's your population you're looking at, Riley? Those that use the placebo, and out of that group, what are you looking to see? There you go. So it's improvement given placebo, which means you need to find the probability of improvement and placebo over the number of people who use the placebo. Looking at what's there, what would this simplify, or what would this look like? I don't need you to simplify it. Hands up, please, when you can tell me. We got one. We'll wait for 6 of you. 2, 3, 4. 5. There we go. Questions on that? There's one. So these start getting a little bit redundant. Yeah, so we may come back to these, but there's one more that I want us to get through today. So we've got some in here. Bounce over, please, to page 21. We may come back to that if we have some time at the end. I just want to make sure we get 21 done. Or sorry, beginning tree diagrams. You all, from what the other classes have said, are familiar with tree diagrams, yes or no? Okay. Maybe after you see them, hopefully they'll be easy for you. They go left to right, there's branches, yada yada. Looking at this, a tree diagram represents all possible outcomes visually and assigns probabilities to the event if they aren't even probabilities to begin with. Draw a tree diagram that represents a coin being tossed twice. Include the probabilities. So let's start off with this. How many outcomes are there if I flip a coin? Hands up, please, if you can tell me. How many outcomes there are if you flip a coin? The questions get substantially harder. Got phrase. Sam? 2. Very good. Sam, if you're not tired, what are those outcomes going to be if you flip a coin?
Tails.
Or? There you go. All right. Now, I'm going to go through and flip the same coin a second time. How many possible outcomes are there for when I flip the coin the second time? Hands up, please, if you can tell me. I've already flipped it once. I'm going to flip it a second time. What are the potential outcomes from my second operation? Yes. Heads or tails. Wonderful. Now, what's the probability of getting a head on the first flip? Hands up, please, if you can tell me. What's the probability of a head on the first flip? Connor? Okay, now, I don't like the fractions. What am I a fan of? The decimal. You're right, it's 1/2. What could it be as a decimal? So you can pick which one you want to label this with. I love the decimals. What's the probability that we get a head on the second flip? Well, that's still 0.5. It doesn't change. Like, here's one that I always find interesting. So I had a friend, and they had 7 siblings when they were growing up. So there were 8 total children. The mother had 8 girls. 8 out of 8. Why did they have so many children? Because they wanted a boy. And the false logic that they kept going is, listen, I know, and these were probably the exact conversations that they've had. They go, honey, I really think we should have another child. All right. I know you really, really wanted to have a boy really, really badly. We've had 3 girls. We're probably going to have a boy next, because we've had 3 girls. And they go, right. And then they go, and then they have the baby, and then they come back, and then the doctor comes in and goes, congratulations, it's a girl. So now they've got 4. And then they're going to go, all right, we're going to try one more time, honey, because this is it. I mean, what is the probability that the next kid's going to be a girl again? Look how many girls we've had before. Except what's the probability of having a girl on your 5th child? 50%, it doesn't change. It's not like your body is sitting there and going, oh, wait a minute. We've had 4 girls before, let's make this one a boy. That's not how biology works. The probability is the same every single time. That's why when teams lose a coin flip, they go, well, what did we have last time? All right, well, it's probably not going to be. No. What you had before, it's not like the coin knows that what you got before It's some magic coin that keeps, it's only going to be heads when you flip it. It's not how it works. And these poor people have 8 girls running around now. And listen, I think there's even 8 girls alone in here. Can you imagine 8 girls under one roof? They had to build on, they put an addition on their house that was just an extra bathroom downstairs and upstairs. They didn't even add bedrooms. They just needed bathrooms because there were so many people that went through and had, I think all the, girls will say, I'm not trying to be precious, but I will. Because of the house that I bought from these people, there was a father, a mother living in the house, and 4 girls. All right? Now, I moved into this house. I needed to have a cleaner come and clean it, first of all, because for some reason girls shed like dogs. Like there's giant all over the place, and I know this from my sister. Even when I was growing up, you go to take a shower and you walk in the bathroom, and what's all over the tile? It's so vile, and I walk in and I almost vomit. I needed to have the drain snaked. You know what that is? Yeah. And the guy comes out, and he looks at me after seeing this gigantic, I think it might have even been, it just probably looked like a raccoon, right, that he pulled out of this drain. He goes, that's a lot of hair. And then he looks at me and goes, where did that come from? Obviously, it wasn't me. So that's why I can sit there and I'm like, I can see why my friend's family built 2 extra bathrooms on their house. Now, understand, just because something happens once doesn't impact the probability of it happening later. That's something very, very important. And again, we talk about how math is important. This is a tax. We'll say this. Not knowing math is a tax on you the rest of your life. Like the people that go through and play the lottery. To figure out the likelihood of you winning the lottery, it's pretty much this. Imagine an airplane completely hollowed out and filled a big 747. Sorry. I think it was 787, huge ones, with 2 levels. Imagine that hollowed out and filled with ping pong balls. And then imagine 7 of them next to each other, all hollowed out and filled out with ping pong balls. Your likelihood of winning the lottery is the same as me reaching into one out of those 7 airplanes and pulling your ping pong ball out. Would you take that chance? Would you? Why not? Because it costs money. That's why. It costs $1 or $2 to go through and play. And they do it, and it's disproportionate. People who are winning, we'll put it this way. Do you think Bill Gates is like, all right, I'm really going to get rich this time. I'm going to play the lottery? Do you think that's how it works? Do you think Einstein played the lotteries? Get real. Now, here's our probabilities. You can also see conditional probabilities if we go through and do this. We can evaluate something given something, yada, yada. Now, this would be, so we'll go forward from here. Take a look. Here's one that I'm going to list out on the next page. And this one actually applies to you all quite nicely. Read what's there. Read the given conditions. And we're going to make a tree diagram for this set of data. I'm going to make a tree diagram to represent this. How many branches am I going to have off of my first choice? Hands up, please, if you could tell my initial classification. How many branches am I going to have off of that? And this is the reading part. You've got to do something. So if you don't know, you go back and read what's on there. Royce, how many branches do you think I'm going to have off the initial classification? 3. What are they? Okay, so I make mine nice and big so we can see. We've got group A, B, and C. And then off of each of those, let's say group A gets chosen. How many branches are there going to be off of A? Hands up, please, if you can tell me. Tom, how many do you think? tell me how many branches they think are going to be off of A. 2. What are they? Off of group B, how many will I go through and have? John? 2. And what are they? And what about off of group C? Anthony, how many am I going to have? So make sure that this is down on all of your papers to start. Now we can go through and assign probabilities. What's the probability that group A is selected? Hands up, please, if you can tell me that. Read what's there. Probability group A is chosen. Mickey, what do you say? What's that? Is it? No, I don't think it is. I thought. You can tell me what the probability of group A is going to be. Do you know?
22%.
Yeah, so I'm going to do is 0.22. What's the probability that group B is chosen? Hands up, please, if you can tell me that. Kirsten, what do you say? And then the probability that group C is going to be chosen, Philip, is what? 0.35. Is that what we got? Yes or no? Okay. Now, what's the probability that they're in group A and they have an accident? Hands up, please, if you can answer that. Yep. 0.5, which means no accident would be what? 0.5. What's the probability that they're in group B and have an accident? Megan? Oh, wait, is it 0.5 or no? Is it even? 0.11, sorry. Which means the probability that they don't have an accident would be 0.89. What's the probability that group B has an accident? Hands up, please, if you can tell me what that's going to be. Megan? 0. What? 0.3? Is that right? Or is it 30%? 3%? Okay. And then this would be 0.97. What about group C? What's the probability that group C has an accident? 0.02. And then this would be 0.09, 0.98. Now, looking at what we have here, let's answer out some of these questions. We drew the tree diagram. What percent of them are expected to have an accident during the next 12 months? How can you figure out the probability that they're going to have an accident during the next 12 months? What would we have to do in order to compute that out? I've got to try something. We have a lot of people who become lumps in here. Right?
Add up all group A, B, and C, the percentage of people that have accidents.
So how can I compute somebody's probability of being group A and having an accident?
Well, I was just gonna say add 0.11, 0.03.
Nope. We got to do more than that. Yeah. No? How do you find, yeah, Riley? 0.11 times 0.22. Go ahead. And then, because that's the probability that you're in group A and you have an accident. What's the probability of being in group B and having an accident, Riley? What would you have to do? 0.43. And then to that, we're also going to add our third one is 0.02 times 0.35. Go through and do that right now. Compute what that probability itself is going to be. You're not going. What do we get? I'll wait for all of you. Ken, did you get it? No? Sam? Sam, what'd you get? Now, this is not correct, though. Why? Why is this not right? So it would be 4.41% of people. Your homework is go through, please, and finish those questions on pages 18, 19, and 20. Finish those. There's 6 questions, I think, total. We'll probably make it graded next time. We'll see who does it and who doesn't. Wouldn't that be fun?
No.
Would be for me.